Okay, we have been working on multiplication of polynomials, and it is nice if you can have some memory devices and be aware of some special patterns that come up with some frequency. So that's what we'll look at next. And we're especially going to look at the case of two binomials. You'll be doing a lot of multiplication with two binomials. The first thing we'll look at is something called FOIL, and that's just a memory device. You've actually already seen it. We're just going to practice with it some and give it a name. We're going to look at the product of the sum and difference of two terms, which is going to have a special name applied to it later on when we factor. Going in reverse, we'll have a special name. And squaring a binomial, looking at a perfect square. So let's begin with FOIL. FOIL is used and will work every time for multiplying two binomials. If you forget any other special pattern, you can always go back to FOIL and work it out. It will not fail you. The FOIL stands for first, outside, inside, and last. And what it is it's a pattern that we get when we use the distributive property and multiplying two binomials that comes up if you do the little arrow trick. So let's take an example of 3x minus 4 times 2x plus 3. If I were to draw arrows to make sure that we're matching up, sharing out, distributing each little piece, whatever phrase you want to use to help you remember, we're going to end up with the 3x times the 2x, then the 3x times the 3. Well, there's your first and your outside multiplied together. And then minus 4 times 2x inside, minus 4 times 3 last. So let's apply that. Our first, 3x times 2x plus outside, 3x times 3 plus inside, negative 4 times 2x. Remembering that we can always write a subtraction as the addition of the opposite, plus last, negative 4, forgot my I for inside, L for last, times 3. Now we're going to simplify this, clean it up a little bit. 3 times 2 gets us 6, and we have an x squared. We'll have here a 9x minus 8x minus 12. We can simplify this a little more by combining like terms. 6x squared plus x minus 12. Now, we just want to practice that a little bit with some different examples. Since it is a very useful tool, I want to practice it a little extra. Let's look at 6a minus 5b times 3a plus 4b. Again, we'll go with our first. 6a times 3a, 18. A squared. You can even skip writing out that step as long as you go with care along the way. Outside, 6a times 4b is going to be 24ab plus the inside. Minus 5 times 3 is a minus 15ab plus the last. Minus 5 times a 4 gets us a negative 20b squared. Now again, we can add together our two middle terms in this lineup. the AB, because they're like terms. We'll have an 18a squared. 24 minus 15, better be a 9, AB, and then our minus 20b squared on the end. Much faster than the long, full-blown distributive property. Now we're going to apply FOIL and work into the second goal, looking at the sum and difference of two terms. We'll apply FOIL to that and see what happens. More opportunity to practice FOIL. Let's take the very simple case of x plus y. First term is x, second term is y. We've added them up, so we've got a sum, times x minus y. Now we're going to multiply by the difference. And let's just FOIL that. I'll write a big equals with the word FOIL over it, so you can see what I'm doing and have more free space here. X times x is x squared. Outside, minus xy. Inside, plus xy. Last, minus y squared. Got to mind those signs, especially on the end there. Well, plus xy and minus xy, I'm going to add to 0. It's a very beautiful thing. They're gone. And we are left with x squared minus y squared. So when you have a sum and a difference, no matter how fancy those individual terms are, if they're added in one set of parentheses and subtracted in the other, and you multiply them, you're going to end up with just squaring each and putting a minus sign in the middle. So you have x plus y times x minus y is x squared minus y squared. This would be a very useful pattern to memorize because it will come up again when we start undoing multiplication and factoring. Again, what I would call flashcard fodder.